Use the data in the contingency table above to test at the 5% significance level the hypothesis car type is independent of owner's age, car type is not independent of owner's age. Well, I happily have my little table here, which is in your book. And what we're going to do is we're going to fill out this table in order to help us test it. Now, to do that, I need to know, for example, how many people I expect to be under 30 and have a saloon, or over 60 and have a saloon. Now, you should know from previously, to do expectation, it's n times by probabilities. So I'm going to do n, which is 360, times by, in this instance, the probability of someone being under 30 and have a saloon. Now, I'm assuming they're independent, so probability of being under 30 is 134 out of 360. Sorry, 68 out of 360. Probability of having a saloon is 134 out of 360. So what I would do in my little table that you can just see down here, in this cell, which I'm writing in black, I need to write in a different colour. In this cell, I'd have 360 times by the probability of saloon and under 30, which is 134 over 360 times by 68 over 360. And if I type that in my calculator after pausing, that gives me 25.31 recurring. So 25.31 and the 1 recurs. I'll probably only do to a couple of decimal places. Now, this is the expected value for each of these. So what I'm going to do is I'm going to fill out the rest of this table by doing the same principle. So this cell here will have 360 times 134 over 360 times 184 over 360. This cell will be 360 times 113 over 360 times 108 over 360. And all those numbers I'll put in this table here. So hang on a sec. So there we have it. The expected frequencies in the cells all filled out. And remember, the expected frequency, it's the product of the marginal totals for each of these divided by the total number. So I've been doing 360 times 134 over 360 times 108 over 360. The 360 will count, so if you just do that number times that number divided by that, you'll get these values. Now, these are expected frequencies in each of the cells. What we're now going to do is we're now going to double check each of them are large enough to do our chi-squared. Now, that's quite important. Usually, all your expected frequencies need to be greater than 5, and I'm just noticing that this one over here, at 6.8, that's not bigger than 5, really that much. So what I might be is a little dubious of that. I can still do it, but I'd be a little dubious. And what might often actually be better sometimes is to combine some groups. So for example, that one, if it was less than 5, I might combine the under 30s with the 30 to 60 range, thereby giving me a larger group, making my expected frequencies to be bigger than 5. So what's next? Well, the next bit is to fill out another table. Look at that, very Blue Peter-esque. And what we're going to do now is do our formula, which is our observed value. So in this case, I'll do this in purple, in this case 10, we're going to take away our expected value, which was 25.31, and we're going to square all of those and divide it by the expected frequency. Now, to do that, I'm going to need to fill out this little table with all of those values. So what I'm going to do is take my 10, and again I'll do it for this first. I'm going to take 10, which was my expected value up here, sorry, my original value, the one I observed. I'm going to minus the 25.311, then I'm going to square it, and then I'm going to divide it by the expected frequency, which was my 25.311. Now that gives me a value which I'm actually going to put in here, which is 9.262. And so those values I'm going to fill out in each of those cells. So that is my observed value. Let's just move across so I can write this in. So it's observed minus expected squared over expected. And I'm going to do that for each of the 9 cells in here. So if you hang on a So the sum of all of these values is x squared, which comes out to be, on my calculator, 66.0 749. So basically I'm all ready and good to go to find out whether or not this is significant or not. Now the question asked for the 5% significance level, so it's the 5 significance level, and I also need my degrees of freedom. Now my degrees of freedom, I've got 3 by 4, so take one off the 3, I get 2, take one off the 4, I get 3, so 2 times 3 gives me 6 degrees of freedom. Can't spell, I was going to write significance level again. Degrees of freedom. So what I'm going to do is have a look at these two on my chi-squared table. So here's my formula book, and I'm looking at the 5% level, and I have 6 degrees of freedom, so 12.59. So that effectively is the value that I'm looking at. So let me just write that down. 12.59. And given, in this case, that my 66.749 is greater than 12.59, which is my critical value. So critical value. So given that 66.749 is greater than 12.59, that shows that I'm going to reject the null hypothesis and accept the alternative hypothesis that the car type is not independent of the owner's age. So car type and owner's age are basically implied. Yeah. I'm not going to write all of that down, but that's what you would write down. So let me just do the H0 rejected, H1 accepted, and our H1, if we go all the way back to wherever I put it, car type is not independent of the owner's age.